All right, we're going to go ahead and get started. I appreciate y'all sticking around for the last presentation of the day. So thank you so much. So my name is Kristen Johnston. My co-presenter was John Pierre with the City of Dunn. Unfortunately, he was unable to attend. So I'm going to trudge on. But we're going to present the use of GIS technology in the LCRR service line inventory. So quick agenda here, just overview, introduction, give a little bit of background regarding the city as well as the LCRR, talk about our project goals, our methodology and technology. Thank you. Next steps, and then some key takeaways that we've learned from the project. So over your introduction, again, I'm Kristen Johnston. I'm a business analyst with KCI Technologies. We are a professional services firm. I'm in the geospatial group. KCI is not new to North Carolina, but our geospatial group is. I've been on board for almost 2 years now. So we have 7 offices in the state, our largest in Raleigh, then Asheville, Wilmington, a couple in the Charlotte area, Lumberton, and then next door in Greensboro. So we began this journey with the City of Dunn last year. And to give you a little bit of background for the city, they are located in Harnett County. It's about 40 miles south of Raleigh, about an hour off of I-95. They have a population of about 10,000. They are in the fastest growing area in the country, one of the fastest growing areas in the country. And historically, they have been based in agriculture, manufacturing, and distribution. So a little bit of background on the LCRR. Many of you probably are familiar with this already, but essentially it stands for Lead and Copper Rule Revision. There's also the LCRI, so many acronyms, but the Lead Copper Rule Improvements. But essentially they are built upon the LCR, which was implemented in 1991. It's essentially safe drinking water regulation, and the goal is to reduce the levels of lead and copper. Timeline there, the LCR was published in 2021, effective later that year, and then ultimately compliance was necessary by October of last year for the baseline inventory, that is. So a couple of fun facts. This is for public water systems, and depending on the corners of the internet you might search, there's roughly 148 to 154,000 public water systems in the country, with around 50,000 of those being community water systems. Another fun fact, 80% of the US population receives their potable water from a public water system. So if we have roughly a population of 340 million, that means around 272 million people receive their potable water from a public water system. Pretty mind-blowing. So why is LCRR important? Obviously, safe drinking water regulations, its additional requirements on top of the existing LCR. Essentially, lead and copper can cause or have adverse effects in our health. The EPA determined there is no safe level for lead. And the action level is 15 parts per billion. If you do the math on that, that's 0.015 parts per million. And if you compare that to the copper action level at 1.3 parts per million, essentially it's 86 times less than that copper action level. So as we all know, lead is detrimental to our health, especially for the very young, especially children under the age of 6, and of course the elderly or those with compromised immune systems. It can cause behavioral and learning problems, lower IQ, slowed growth, hearing problems, anemia, and then in adults, cardiovascular issues, reduced kidney function, reproductive issues, pregnancy issues. So what was the compliance for this past October? It was the initial baseline inventory of the service lines. and then the following notification of the service line material, and then future action plans for any lead level exceedance, and then of course additional reporting. So the inventory includes obviously a locational component, the service line material for both that public and private side, installation date, size, if it was field verified and what the method and date was for that, and then of course, potential sources of lead in other components like connectors, solders, fittings, etc. It won't let me advance now.
Let me see what's going on.
Technical difficulty.
Do you want to just try moving the cursor there and clicking? Will
Okay,
that
I
work
can do
for you?
that. Yeah, that'll be fine. All right. So, of course, there were templates for the initial baseline spreadsheet based on the size of the water system. Essentially, it captured the same information. This is just a cool screenshot trying to put them all on the same page to show you what it looked like. Okay. So project goals. Of course, we wanted to meet requirements, but we also wanted to exceed the baseline inventory completeness, because essentially you could complete your inventory and have things marked as unknown. But the goal was to understand what the materials are so you could effectively notify the public and then take corrective action. Of course, we wanted to be efficient in our time and, of course, make the best decisions for the investigation locations because you have a limited budget. Their data visualization component, maps, say 1,000 words there. We wanted to get the maximum number of investigations and, of course, be able to effectively and appropriately communicate this, not only with the city, but with the public. And so we knew that GIS would play a big role in this, but especially in kind of those 3 blue areas there, it was going to help, again, visualize that data, make the best use of our time, and then make the best decisions for investigation locations. So talking methodology, from a project side, it's a bit of an iterative process. Obviously gather records and compile the data to build that initial inventory, essentially investigate and then update that inventory. There might be some predictive modeling in there, and then again, investigate, update that inventory, and then of course, corrective action, any type of line replacement, and again, updating that inventory and the data behind it. From the GIS side, we worked with the city to gather the records, compile the data. We actually, I think on the next slide, we created some data for them, and then we implemented the solutions. We had a database, of course, and then maps, surveys, and dashboards, which I'll touch on here in a second. So the city did have water utility data with lines, other point attributes, and then of course water service addresses. They had a little over 5,100. We geocoded those for them. And then they also had water sampling locations, which we geocoded. We then created a database, really a hosted feature service, but to capture the field data collection from our SUE and survey teams, and then built web maps off of that. The desktop web map for our engineering and project team included the following data. It was the parcels, which we were lucky to have the physical address years, so when the infrastructure on the address was built. Of course, the zoning or land use, the water data I mentioned with the utility infrastructure, service addresses, and sampling locations. And then, of course, we brought in different socioeconomic data to look at sensitive population areas like hospitals, child care facilities, elder care, schools, affordable housing facilities, and then disadvantaged block groups. This is just a snapshot of the city's parcels by decades that infrastructure age. And they had infrastructure in their database dated back to 1890. And so we went every 10 years up to 1986, of course, after that lead was banned. So the dark red are the older parcels, and then the dark blue are the parcels up to that mid-'80s time frame. Anything that is white was after that mid-'80s time frame. Here's a little zoomed in. Like most municipalities and even large cities, usually the infrastructure at the core is older than that on the periphery as it moves out. A couple other snapshots here. This was locating, again, those potential sensitive population areas like the hospital, child care facilities. The pink or red is the disadvantaged block groups, and then public schools, private schools, so on and so forth. This is a snapshot of the service addresses, and the highlighted yellow ones are those that are those sensitive areas, again, the schools, hospitals, elder care, child cares, et cetera. So all this was compiled into the web map for the project team to evaluate, do some overlays, look at data, and essentially they came up with areas of interest, and they marked that by the parcel. So the red blocks throughout here are different parcels that they were interested in taking a step further in the investigation. So based on the parcels 1986 or earlier from the infrastructure data, we had approximately 3,400 unknown, and the number of required investigations for that range was 341. So that was our target for field investigations at this point. So we started with 75 investigations. We sent our SUE, which is subsurface utility engineering, and our survey teams out, and we did you dig a hole, hydro extraction, dig a hole, look, see if you can find the line, test it if it's lead, magnet. We started with 75, and then we kind of reevaluated, looked at the number of sensitive population areas we needed to hit, and we've to date completed 228. So we have roughly 113 left. As I mentioned, our crews went out. Our teams did not go out necessarily at the exact same time. Sue was usually a little ahead of our survey, so they would mark the locations with stakes for the survey to come back and shoot the shot with the high accuracy. And essentially they located the meter as well as, again, that public side, that private side, roughly 18 inches to either side of the meter. We sent our SUE team out with an iPad and a Field Maps app. And then survey, of course, came back. They were using the Trimble R12 GNSS. So the field app that our SUE team used had the parcels, again, those areas of interest, which were parcel-based, the utility infrastructure, the service addresses, and then roads. They would dig the 3 test holes, and we also set up the data to capture additional features that might be nearby. We wanted to be able to capture that data for the city if they didn't already have it in their GIS, so things like valves, backflow preventers, or any type of other infrastructure that they could fill in. So as you know, Esri has an LCRR solution. It first came out in June of 2021. They've had 5 additional resources up through the end of last year. This is a little snapshot of what you actually get when you deploy the solution, and then a few of the attributes from the service line hosted feature layer. There's a total of 51 different attributes in there, from dates of installation and inspections and so on and so forth. But it utilizes, of course, ArcGIS Online with field maps and Survey 123. So like I said, this is an ongoing journey. And so next steps will be collecting any of the private citizen line and identification they may have done on their own and inputting that into the data. And then we are hoping to do some predictive modeling. We are looking to engage a partner in this to run some predictive modeling at our current 228, where we are with 228, to see if we can better identify where we want to target our 113 that we have left. We'll do the ground truthing with those, finish up the field investigation, and update the inventory, of course. And as you may be aware with the LCRR, LCRI, there are additional deadlines moving forward if nothing changes that include the baseline inventory for things like the connectors by 2027, replacement plans by 2027, and then verification of non-lead pipes by 2034, and then complete replacement of any lead or galvanized needing replacement by 2037. We also will be merging our locations because, again, we have data collected from our SU teams, and then the high accuracy shots from the survey. We'll be merging that on the back end to be able to provide that back to the city, and then, of course, work on funding for any lines that need to be replaced. We currently have only found one lead line and approximately 45 galvanized that will probably need replacement. So some key takeaways. Obviously, the GIS technology made this very easy. Again, from visualizing the data, it removed most of the spreadsheet. Obviously, the inventory was a spreadsheet, but from the data collection side, it could get rid of the spreadsheet. And then it really put the data into the team of the project, into the hands of the project team. This, of course, was huge. Regardless of what entity you work for, there's always an internal educational component around GIS and its capabilities. So having engineers getting excited about GIS and actually utilizing that, that's a win. And then our SU teams had not used some of the Esri components. They've used some other proprietary software systems. They had little to no training, but they were off and running very quickly, very intuitively, and they are eager to use the technology in some of their other projects. Just a few acknowledgments here, sources. We've really enjoyed working with the City of Dunn, and like I said, we're continuing this journey, so more to come. And that is what I have. Look, I flew through that. Thank you. Any questions?
You mentioned that there was one lead line that they found. Was there any known lead in the system before the SUV effort?
So the question was, I mentioned there was one lead line found. Was there any lead lines known within the system? And the answer was no. Yes?
So you mentioned that they did have some records of, I guess, the water taps.
The sample. The water sampling locations?
Oh, no, I meant when the crews initially installed the water meter, basically. Did you have any records to go off of from the city, basically?
Yeah. So the question was, did we have records from the city with regards to installation dates for things like water meters, infrastructure in general? There was institutional knowledge. And there were there were some records, but it was not widespread enough to be able to make those generalizations. Yeah, Andrew?
I noticed like when it talks of like fire connections or other like services besides the non-drinking water, has there been any updates as far as future requirements?
The question was, there's been talk of fire hydrants, other potential connectors aside from drinking water. Has there been any updates? I don't know. Does anyone else know that question, that answer?
I don't see.
The fire department connections need to be included. If it's part of the potable water line, though. Yeah. Thank you. Did you have a question?
Yes. When you did your geocoding, how did you know you got an actually good match?
That's a great question. So the question was, when we did the geocoding of the service addresses and then the water sampling locations, how did we ensure we got a good match? We triple and quadruple checked it.
Did you use an address locator?
We did. We used an address locator, but we also, I actually did that part myself. That's why I say we triple and quadruple checked it. We also matched that up with parcels. And so we wanted to really make sure that the address might have hit, but like it's sitting on top of the parcel that has the same address. Yeah. I don't know that what I went through, there was some manual components of that, obviously. I don't know that would have been achievable on a water system of like 50,000, service addresses, but we had a little over 5,100. And we did have a couple, like any geocoding, any data set that you're going to geocode, obviously making sure your data has the integrity it needs to have and the completeness before you run it through the locator. But there always are a few of those that don't code. It would just have an address like Highway 55. Well, that's a very long highway. So there were just a small handful of those. Yeah.
You said that you got infrastructure data in a sense where, like, when buildings were built, you got that from the city of Dunn?
Correct.
Or what was your source for that data?
Yeah, so the question was, what was the source of the infrastructure data, assuming you mean like the built dates that I was speaking about? It was from the city.
Okay.
Yeah. Well, thank you all so much for your time.